morning. It's October 1st, and this is your daily brief in science. Here's everything you need to know. Scientists have demonstrated a proof-of-concept technique that allows human eggs to be created from skin cells, marking a significant scientific breakthrough in reproductive research. This process involves replacing the nucleus of a human egg with one from a skin cell and inducing chromosome reduction. The technique uses an electric pulse and a drug called roscovitin to mimic meiosis, aiming to reduce chromosomes for fertilization. Despite progress, the process remains highly inefficient and risky, with many resulting eggs showing chromosomal abnormalities. These genetic irregularities prevent the eggs from developing into viable human embryos. The research combines in vitro gametogenesis with somatic cell nuclear transfer and mitomeiosis, procedures that are still technically challenging. Experts estimate that refining this method to produce normal, viable eggs could take at least a decade. Achieving proper chromosome division continues to be a major hurdle, raising safety concerns that currently prevent clinical application. Ethical and legal barriers, including bans on genetic modification and embryo research in the United States, further complicate potential use. Significant ethical concerns include the potential for creating designer babies and genetic enhancement, necessitating societal and regulatory discussions. Some bioethicists and scientists believe that with proper oversight, this technology could eventually help individuals wishing to have genetically related children. While still in early stages, this research offers insights into human meiosis and age-related egg errors, with future applications in assisted reproduction. President Donald Trump has signed an executive order aimed at enhancing pediatric cancer research through the use of artificial intelligence. The initiative seeks to improve diagnosis, treatment, and clinical trial processes by leveraging AI technologies. The U.S. Department of Health and Human Services announced that funding for the Childhood Cancer Data Initiative will double from $50 million to $100 million to support this effort. This increase is intended to accelerate research and develop more effective diagnostics and therapies for childhood cancers. Despite recent reductions in overall research funding, advocates and families see this AI-focused initiative as a source of hope for faster medical advancements. Political debates over federal healthcare funding and potential government shutdowns continue to pose challenges to biomedical research efforts. The White House plans to issue a call for research proposals through an open scientific competition, expecting additional investments over time. This move follows a Supreme Court decision allowing the administration to cut $783 million in NIH research funding, though specific AI company involvements have not been disclosed. The broader context includes criticism of previous funding cuts, such as a proposed 37% reduction to the NIH's National Cancer Institute budget for 2026. The NIH's increased funding aims to better utilize data and attract research teams focused on AI-driven solutions for pediatric cancer. This initiative is part of wider efforts to integrate AI into healthcare, with collaborations involving figures like Paul Levesque working with the administration. Experts warn that ongoing funding reductions could slow the development of new treatments, potentially impacting pediatric cancer progress over the coming decades. The Childhood Cancer Data Initiative, launched in 2019, has accumulated extensive data but faces challenges in integrating incompatible databases. The new funding aims to address these issues by improving data utilization through AI, supporting research and treatment development. Recent research from UC Davis indicates that psilocybin, a psychedelic studied for mental health treatment, may worsen postpartum depression symptoms in mice. The study found increased anxiety, avoidance behaviors, and depressive-like symptoms in mothers after administration. It also revealed that hormonal changes during the postpartum period influence how the brain responds to serotonin-affecting drugs like psilocybin. Pharmacokinetic analysis showed psilocin was transferred to pups through breast milk, leading to behavioral deficits in offspring, despite no psilocin being detected in the mother's brains 2 hours after administration. Funding for this research was provided by NIH, the W.M. Keck Foundation, and other UC Davis grants. This highlights the importance of cautious and tailored approaches when considering psychedelics for postpartum mental health issues. The findings suggest that the safety and efficacy of psilocybin could differ significantly in postpartum populations compared to other groups. Most current safety data for psilocybin come from male subjects, indicating a research gap in understanding its effects on postpartum women. Given the limited treatment options for postpartum depression, these results underscore the need for further investigation into the potential long-term impacts on both mothers and their children during sensitive developmental periods. A rare juvenile female great white shark was recently captured on underwater camera near Block Island, Rhode Island, marking a notable milestone for Atlantic marine research. The sighting was recorded using the Atlantic Shark Institute's Baited Remote Underwater Video System, or BRUVs, which has now successfully captured images of a white shark for the first time in southern New England. The footage shows the shark swimming past bait and has been widely shared on social media, underscoring the role of underwater cameras in unobtrusive marine observation. This juvenile female is significant because female great white sharks do not reproduce until after age 30, offering a rare glimpse into early life stages of these predators. The sighting contributes valuable data to ongoing studies of white shark behavior and ecology, especially as these sharks are increasingly seen in New England waters, reaching as far north as Maine and Canadian waters. Researchers note that the presence of great white sharks in the region suggests a possible range expansion or increased activity, with multiple sightings off Cape Cod. The Atlantic Shark Institute highlighted this milestone as important for ecological understanding and conservation efforts. Besides shark sightings, conservation activities include the Mystic Aquarium's efforts to release endangered sea turtles after rehabilitation, and the New England Wildlife Center's creative bandage designs for turtles. Recent initiatives also promote shark safety and awareness, with tips shared by the Atlantic White Shark Conservancy to help the public stay vigilant during peak shark season. While great white sharks are less common in Rhode Island waters compared to species like blue sharks, their earlier seasonal appearance and presence in northern areas like Maine indicate migration patterns and habitat preferences. Public interest in local shark activity increased earlier this year after a viral video showed a 20-foot shark at Block Island's Great Salt Pond, reminiscent of the movie Jaws. That shark was attracted by bait such as herring, and the footage captured during about an hour provides insights into its behavior. Other rare marine animals, including leatherback turtles and large stingrays, were also recorded off Block Island, highlighting the region's vibrant ecosystem. Children who experience multiple COVID-19 infections face increased health risks, including a higher chance of developing long COVID, according to a recent study published in The Lancet Infectious Diseases. The research analyzed electronic health records from January 2022 to October 2023, involving 40 U.S. children's hospitals and focusing on infections caused by the Omicron variant and its subvariants. The study found that reinfection, even if mild, raises the risk of long COVID across all demographic groups, regardless of vaccination status, age, sex, race, or pre-existing conditions. Additional health issues linked to reinfection include kidney damage, arrhythmias, severe headaches, abdominal pain, and significant fatigue, all contributing to the complex clinical syndrome of long COVID in youth. Symptoms in children can include fatigue, brain fog, headaches, breathing difficulties, and behavioral problems, often lasting at least 3 months and affecting school performance and daily activities. The study emphasizes the importance of pediatric post-infection monitoring to identify at-risk children early and implement interventions like cognitive and cardiological assessments. Preventive measures recommended for parents include good hygiene, indoor ventilation, mask use during outbreaks, and staying current with COVID-19 vaccinations. While vaccination remains a key preventive tool, it does not fully prevent reinfection or long COVID, though it is still strongly advised. In Illinois, despite federal guidelines, authorities recommend vaccination for children aged 6 months to 17 years, especially those at higher risk. These developments are part of ongoing discussions around vaccine policies and federal funding cuts for COVID-19 research. Major health insurers have committed to covering COVID-19 vaccines for children this season to improve vaccination rates. Dr. Yong Chen, the senior author of the study, highlights the logistical challenges of pediatric COVID-19 research and stresses the need for sustained funding and data sharing to better understand and address the pandemic. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.